Alright, so for this project, I have to make a video explaining how to make Lewis dot structures for a covalent molecule and a polyatomic covalent ion. So let's start with the covalent molecule. So the one I got assigned is C2H6. Okay, so the way that we're going to figure this out is first we're going to see how many valence electrons C has, and it has 4. So 2 of these gives us 8 valence electrons total for the C's. And then for H, we have just 6, because hydrogen only has 1 valence electron. So 8 plus 6 gives us 14, and divided by 2 gives us 7. And why this number is important is because it's going to tell us how many bonds this covalent molecule has. So this is kind of our way of checking our work to make sure that we did it right at the end. So this number is going to be important later on. Alright, so the way we're going to do this is because C has 4 valence electrons, this is they're sort of outputs that hydrogen can hold on to. So the way we're going to assemble this is put C in the middle. And both C's are going to be in the middle, both carbons. So what we're going to do is we're going to put a bond in the middle, because one from this C and one from this. And so this gives us a line, or a dash. And that looks pretty bad, but we'll fix that later. And up here, we have 1, 2, and 3. So this finishes, so it still has its 4, but it's just sharing it. So they're sharing the bond with each other. So then we put in our hydrogen, and each hydrogen has 1. So this gives us actually a perfect set of bonds between all the molecules. So this is great. So another way of writing this would be C to C and H. And like I said before, we're going to check our work and make sure that we did it right. So 1 bond, 2 bonds, 3, 4, 5, 6, and 7. So this does indeed fit our standards. So that's so we did this right. So now on to the next ion. So the way that the first one and this one are different is that this one has a negative sign right there. And I'm going to show you how to do this. So first off, we have I. And how many valence? This has 1, 2, 3, 4, 5, 6, 7 total. And oxygen has 6. So a way of writing this would be 2, 4, 5, and 6. So the reason I'm doing this is because I'm just splitting it up so that way we can bond more things to it. So first off, we're going to put the O's in the middle. So there's 3 of them. So the way we're going to do this is O next to O next to O. And this works out because there's 2 right here, 2 right here, and they bond to each other, which is fabulous. So in the middle, this is decked out, and it can't handle anything else. So there's nothing else can bond to this middle O. But the outskirts, they both can attach to something else. But the problem here is that we only have one thing that needs to be attached. So the way we're going to do this is where the negative sign comes in, is because we put our I down here and we put on the 7. I don't know if so this is maxed right here. But over here, we still have an empty space right next to this one. And so we're going to add 1. So we're adding 1 electron, and we're just putting it in. So it's happy, and this whole thing is content with itself. But then we're going to have to put this whole thing in brackets and put a -1 on the outside. So the way this is going to look in the end is O, 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 with a bond in between them. And then 1 bond down to I. And If we want, we can even put these out here just to show. Perfect. So then we put our brackets around and we put a negative. And because +1, -1, they cancel each other out. So this works. And this is how you make a Lewis dot structure for a covalent molecule and for a polyatomic covalent ion. I hope you enjoyed. I know I did. Sounds good. All right.